Okay, so for this section, we're going to be solving linear systems by graphing. And I'll tell you right now, we're going to be learning a few different ways to solve linear systems. Once you've learned the other ways, you're probably not going to use this one much anymore, but it is good to know as kind of a foundation. So what we're doing is we're taking our two equations here, and we are going to draw our lines, find out where they intersect, and that should be the solution here. So, okay, so I've gone ahead and set up here. We have our first equation, x plus 2y equals 7. Okay, so we're going to go find our points. So the first one, we can go in, we put x in for 0, or I'm sorry, 0 in for x. That'll leave us 2y equals 7, so obviously that gives us 3.5, or 7 over 2. For our y, we have 0 here, so if we put that in, 2 times 0 is 0, and that's just going to leave us x equals 7. Okay, then we're going to come over to our second equation over here, and that's 3x minus 2y equals 5. So again, if we put 0 in for x, 3 times 0 is 0, negative 2y equals 5, so that's going to give us negative 2.5. And for the y, if we put that in for 0, that's going to leave us with 3x equals 5. So we'll just make this 5 over 3. I've kind of mixed our decimals and our fractions, but that's okay. So we're going to go in and draw our two lines. So we go back to our first one. Our first point was x is 0, y is 3.5. So we're going to put a little point here. And then our second point, x is 7, and y is 0. Okay, so we're going to put our point there. We can draw our line through those 2 points. Okay, then we come over to our second line. So we have our x is 0, and our y is negative 2.5. Okay, so that's going to be about there. And then our second one, our x is 5 over 3, so 1 2/3, and y is 0. So that's going to put our point right here. Okay, so then we can come through and draw our line. And what you're going to see immediately here is that this is why this is not the best way to solve these, is if you look over at where my points are intersecting, you can kind of guess, because it's a strict math book problem and we're at the beginning of the section, you can guess where they wanted this to end up, so where it would have been right on our point here. But it doesn't actually quite get there because we're not using like perfect measuring for getting our lines. So, but anyways, we can tell where they're where we're close to there. So we're gonna put our point is at x is 3 and y is 2. And what we can do then to make sure that that's right is we can go put them back into our equation. So if we take that and put it back into our first equation down here, so x would be 3, y would be 2, so 3 plus 2 times 2, that's 4, that gives us 7, so that one is good. Then we can come back and check it over on our second one here. So 3 times x, which was 3, so that's 9, minus 2 times 2, that's 4, so 9 minus 4 is 5. So that's how we know that we have the right solution for that problem. Okay, so let's go back over the 3 steps that we have for solving a linear system using the graph and check method, which is the one that we're using in this section, graph and check. So step 1, that is to graph both equations in the same coordinate plane, just like we did for ease of graphing. You may want to write equations in slope-intercept form. We didn't do that in the first example. I did the 2 points, but we'll switch over to slope-intercept on the next example. For step 2, you're going to estimate the coordinates of the point of intersection. So again, we didn't have exactly on the point that we wanted, but you kind of tell where it was supposed to go. Then for step 3, you're going to check the coordinates algebraically by substituting into each equation of the original linear system. So that's the step that you want to do on these. Again, this is not my favorite method, but we'll go ahead and learn it today, and you won't need to do it too much in the future. Okay, so here's our next example. So this time we have negative x plus y equals negative 7. So again, with this one, we're going to go ahead and put everything into slope-intercept form. So we're going to make this y equals at our x over. So this will be x minus 7. And then, so that's going to make our slope would just be 1, so it's just 1x, and our y-intercept would be at negative 7. Then on our second one, x plus 4y equals negative 8. Okay, so we're going to come down, we're going to do 4y equals negative x minus 8, and divide by 4. So we're going to have negative 1/4 x minus 2. So our slope on this line is going to be negative 1/4, and our y-intercept is going to be negative 2. Okay, so let's go put these in. So we're going to take our first equation again, where we had a slope of 1 and a y-intercept of negative 7. So we go down to negative 7. Rise 1, run 1. Rise 1, run 1. Okay, so we're just kind of going along this line here. Okay, so there's our first line. Then our second, our y-intercept is going to be at negative 2. Okay, and with this one, we have a slope of negative 1/4, so we're going down 1 and over 1, 2, 3, 4. Okay, so that's going to be about right there. Again, we're not ending up exactly where we wanted our line to end up, because it's not always the easiest to draw your perfect lines here. But again, we can pretty much tell that the point that they were trying to get us on was 4 and negative 3. And this, the reason I don't like these with the lines where you're not quite as precise is, with math problems, they're made to work out nice and smooth, but in real world problems, another way of solving these is probably going to end up working out better. Okay, so let's go take our points, put them back into our equations, and make sure that this is going to work. Okay, so we had 4 for our x. We're going to put that back in here. So we have negative 4. Put our negative 3 in for y. So negative 4 minus 3 gives us negative 7. So that's good. Then we can go back and check on our second equation. So our x again was 4. And our 4y, so that would be negative 12. So 4 minus 12, that would give us negative 8. So once again, we do have the correct solution here. So 4, negative 3.